Storage is a very important part of fault tolerance. If something were to happen to a company's data, such as a disk failure that results in data loss, then that could have a serious impact on how the company performs. That's why we need to make sure that if a disk does fail, that no data loss would occur. And one of the best ways to prevent data loss is RAID. RAID stands for Redundant Array of Independent Disks. In a RAID setup, the data is copied on multiple disks, so that in the event of a disk failure, no data would be lost. Now there are 4 common types of RAID. There is RAID 0, RAID 1, RAID 5, and RAID 10. Now RAID 0 is not fault tolerant. In fact, RAID 0 shouldn't even be called RAID, because not only does it not provide fault tolerance, it actually increases the chance for data loss. Because in a RAID 0, the data is not duplicated, but it's actually spread or striped across 2 separate disks. So if just one of these disks fails, or if you decide to destroy it yourself with a hammer, then all the data would be lost. So the only reason why you would want to use RAID 0 is speed, because when you have 2 disk controllers working instead of 1, then accessing data is much faster. Now RAID 1 is fault tolerant. In a RAID 1 setup, the data is copied on more than 1 disk. So disk 2 would have the exact same copy of the data as disk 1. So in the event of a single disk failure, such as getting destroyed by a laser beam, then no data loss would happen, because the other disk would have a duplicate copy. Next, we'll talk about RAID 5. In order to use RAID 5, you need to have 3 or more disks. RAID 5 is probably the most common setup that is used, because it's fast and it can store a large amount of data. So in a RAID 5 setup, data is not duplicated, but it's striped or spread across multiple disks. And in addition to the data, there is another very important piece of information that is being evenly spread across all the disks. And this information is called parity. And parity is used to rebuild the data in the event of a disk failure. But there is a downside to RAID 5, because since the equivalent of an entire disk is used to store parity, it reduces the collective amount of data that can be stored in this array. So for example, if all 4 of these disks were 1 terabyte each, that totals 4 terabytes. But in a RAID 5 setup, the total amount that would be used for data storage would be 3 terabytes, because the equivalent of 1 entire disk would be used to store parity. And finally, there is RAID 10. And RAID 10 is basically what the name says. It's combining RAID 1 and RAID 0 together, and you need to use a minimum of 4 disks. So in a RAID 10 setup, a set of 2 disks are mirrored using a RAID 1 setup. Then both sets of the 2 disks are striped using RAID 0. So RAID 10 benefits from the fault tolerance of RAID 1 and the speed of RAID 0. But the downside in a RAID 10 is that you can only use 50% of the capacity for data storage. So if you are using 4 disks in a RAID 10 setup, you can only use 2 of them for actual storage.